It's repair day here in the lab today.
Could this scene take place in your household?
Hey, Mom. Oh, Mom, you know about that radio that went dead this morning? Pop said he'd fix it tonight. Well, he did. Our radio's in a worse mess than the alarm clock was when I went to work on it.
Good day, and welcome back to Mike's Radio Repair and Restoration. If you're enjoying the series of videos that we're creating here, why not give us a like and a subscribe? We could really use the support. Today we have a SX-100 here for repair. The SX-100 Hallicrafters unit is a very nice receiver. I have one, and it's almost one of my daily drivers. This one here's got some issues we're going to look at with brought in. The customer is complaining occasionally he gets a shock from the outer case. Well, that's not good. The 80 meter band calibration is off by at least 20 kilohertz. So we'll take a look at that. And the 80 meter band is somewhat deaf, although it works not anywhere near as good as the other bands. Customer states the unit has been restored. Customer has asked us to repair it and give it a check over. So that's what we're going to do. Okay, let's verify the first customer's complaint about getting a shock on the outer case. Now, I'm questioning the restoration job that was done on it, as they did replace the line cord. They put a new line cord on, but it wasn't grounded. It's only a 2-wire cord into a hardware store type replacement polarized plug. We'll see how that's wired. So we'll turn it on. I have one of my my meter set to the ground of the 120 volt box, and I've got my others here, and I'm set on the 250 volt scale just in case it's a high voltage. And it's pretty much 60 volts bang on. Well, isn't that suspicious? So we can eliminate a bunch of things by removing the rectifier tube, which I've just done here. Let's turn it on again. Okay, so now we're zooming in on the power transformer and feed area. So now I've turned it off, and just for shiggles, it's off. Well, look at that. That's a lot more voltage there all of a sudden. That's the full 120 volts on that. So that kind of sort of leads us to believe a couple of things. There are a couple of noise filtering caps on the AC line. They didn't change them if one of them shorted. That could possibly give us that result. And unfortunately, a leaky power transformer could give us that result. I think one of the filament leads to the 5-volt filament feed for the rectifier tube is still connected, but I don't believe that would give us exactly 120 volt line voltage. So I think we're dealing on the primary side of the transformer. So I guess the next deal is we got to peel a case off, have a look at those caps underneath, and do some measurements there. So when I get the case slipped off this, we will come back. Okay, here we are looking at the bottom with the cover taken off. Let's go through what I see here. To me, the problem is quite evident. However, we're going to prove it. So they brought the new line cord in, nicey nice. There's one of the AC filter caps here. I see they put a bit of a fuse holder in here. I guess it'll do. Maybe I'll look at it, see what its rating is. But this is the other filter, AC line filter cap. That's a poly cap they put there. And I can see that it's rated for 1600 volts, but I don't think it would stand up to some of the transients that comes in on the AC line. It's my guess at this point in time that this has failed. Second guess would be that this has failed, but let's prove it. Let's set up and see what we can find. Well, that was indeed the issue. I've cut this poly cap here loose. You can see I moved it out of the way. We're still grounded on the chassis. Nothing on the meter. So, as I thought, that cap wouldn't stand up to transients. So the fix for this part of the customer's complaint is going to be putting a 3-wire cord in, 2 new Y-class safety caps, maybe a fuse holder. We'll see how much space I got back there. I don't know if I'm enamored with that one, so that's what I'm going to do next. And maybe while you're looking at this chassis, if you notice anything strange, I do. I can see that they've changed the filter cap, and when they did that, a couple of new resistors went in. But when I look at the rest of the unit, all the resistors are original. I can see it's been recapped, no doubt about that, but I don't believe that they've gone through the resistors. So that's going to be something I'm going to do because that can affect performance quite a bit. Now, the customer said that this was only down on 80, so strong suspicion it's probably an alignment issue. But if I'm going to spend the time to do the beast of alignment on this radio, let's make it right. Let's make sure that all of our plate and cathode resistors are up to snuff. We're going to test all the tubes, make sure the tubes are all up to snuff. You don't want to be putting a great deal of time into alignment if the foundation's not correct. So those are the things we're going to do. So first, though, it's going to be the line cord, the safety caps, maybe the fuse block. So we'll come back when I have that done. Okay, to recap, I put one of my infamous used computer cords on, the strain relief. I did break down and I put a proper fuse holder in. I took that other, whatever it was, out. I put in 2 Y-class safety caps, completely rewired the power feed. Right now I have it plugged in, 0 volts. And I can even go right down to the 2.5. Let's turn it on now, because we had this problem both off and on. Dial lights are on, nothing. So that's fixed. The next part of this operation is going to be addressing the performance issues. So for me, rather than panicking going, where do I start? It's really very simple. I'm going to start at the first tube, which is V1, which is an RF amp. I'm going to pull the tube. I'm going to test it. While the tube is out, I'm going to check the plate and cathode resistors for that tube as I go. So I'm going to go through this complete set as far as I can. This set, if some of you know it, it's a dual IF, so it starts off at 1650 and gets converted down through a second mixer to 50 kilohertz. So that second oscillator is on another chassis that's mounted on top of this chassis here, and they call it just that, the second oscillator chassis. And it's a bugger to get off. There's 2 tubes attached to it on the top. There may be some bad resistors in there. I'm not going to take that second oscillator chassis off at this point yet until it's proven that I have to. If I have to, I have to. So be it. Maybe I can find a way to measure some of them from the bottom. You can see this is the hole here where the second oscillator wire feeds come out, and it's a bit of a zoo to get to. So, and I'd have to talk to the owner before I spend that much time, because that's probably, I don't know, 4 hours worth of time. So right now I'm going to pull each tube in the RF string and the IF string, and do the resistor check, do the tube check. We'll see what we find before we make any other decisions. So not so hard, 1 tube at a time, check the resistors as we go. That was a bit of a surprise. I changed a great number of resistors. And I proceeded as I stated I would, where I would remove a tube and check all the resistors around the given bottom of the tube and test the tube. So something else clearly came to light that I kind of sort of knew about, but this is a good learning journey right now, is the owner of this radio bought a package of new tubes off eBay. And he thought it would be a good idea to put all brand new tubes in the radio. And anybody who's dealt with tubes knows that can be pretty dodgy. And when I knew this radio was coming to me, I asked the owner to bring me the box of old tubes as well. And I'm glad that that happened, because I changed 4 brand new tubes, all Jan tubes that tested rather weak, that the original factory tubes tested much stronger. And this is kind of a norm, unfortunately. Um, Getting tubes nowadays is a dicey business. I would rather get a new old stock RCA or something along that line, a Raytheon, than a newer Jan tube, but that's me. Um, so the moral of the story here is to not run out and buy a bunch of brand new tubes for your radio unless you have to buy one that you know is bad. Often they don't go bad. A lot of tubes, they last a good long time. So I know as confusing as that is, you got to check them, maybe test them in circuit. That's all you can really do is one at a time and take it from there. So like I said, I put a bunch of the old tubes back in. I did take the second oscillator chassis off and replace 2 resistors in there. And same with the rear chassis for the 50 kilohertz IF. There were 3 resistors in there that were replaced, plus a number that you can see here. As I said, I put a proper fuse block in it and all kinds of resistors and whatnot. So some of the resistors had quite drifted, like a 39K resistor had drifted up to 47K, things like that. A 3300 resistor had drifted up to 4400. So, and they're all in the plate cathode area, so they're all going to make a big performance difference. When this radio came to me, I plugged it in, turned it on, tuned around. I didn't hear much on the broadcast band. I didn't hear anything on the 80 meter band, which is band 2. And I heard 1 or 2 tiny little stations on band 3, and I didn't go any further. So my guess is that between the bad tubes and the bad resistor, this radio suffered in performance, not just on 80 meters, but on all of the bands. So let's just set this radio down, connect up a speaker and antenna to it, and see how it performs. It's kind of later in the evening now. A lot of stations may be off the air, but we'll just tune around. Another thing that I want to mention is tomorrow I'll be doing a full alignment on this radio, which can be quite a chore. I have my own set ways of doing it. It's a little bit different than the manufacturer because I get a little bit better results because the test equipment is different now, so I can get more accurate results. But when you change plate voltage to a tube, which we've obviously done by changing some of these resistors, you change the impedance sometimes, the input-output of the tube. So you need to tune upstream and tune downstream, and even just changing a tube. Really, alignment should be next if you're going for the goal to tune a radio so that it can be everything that it can be, so to speak. So we've done enough fooling around here, and we've changed enough plate voltages that a full alignment without question is now in order. So I'm just going to pause this. I'm going to set this radio down and connect it up. Let's see what we can get. Okay, I got my 100-foot long wire connected, my big speaker. Let's turn it on and see how it goes. We'll start right down the bottom of the AM broadcast band. Let it warm up a bit. Noise.
Air Canada Flight was diverted to Winnipeg after a teenage passenger assaulted a family member.
Parking house was always possible. Check from College Street up to Dewson Street for a police investigation. And a reminder, in Burlington,
Wow, that's not deaf anymore.
Eastport Lift Bridge is closed.
Only 8 in the morning on a way to 135. It's
Health Watch. Most folks don't realize this fact. Our country is
Okay, that works good. Let's go up to the band he was complaining about, but I really think all the bands were down. Okay. There's 2.5 megahertz, that's WWV. You can just hear it in the background. So that's pretty good. That's not deaf. There are other stations in there. Something in there. CHU. 2030 over. We're up in the 80 meter band now. There's the FT8 guys. There's some sideband.
It's a beta thing and whatnot, but I like, I was hooked on the AI thing, and they've already had a couple of revs up on it.
That's not deaf. It's working pretty good.
You just set the voice, is a good thing. And my son that lives there in Texarkana, I bought one.
Lots of little stations in there. Go up a band. See what we got here. WWV at 10 megahertz.
Government accused Israel of seeking to start a regional war.
Changes that are taking place, not for the better.
Much more will it give you the rest of America? How much more will it give you all things? How much more he is going to raise you up and use you and glorify himself?
There's the 40 meter FT8 guys. CW.
De la cavidad bucal. El mayor desafío es que ojo con la
Hear the steam ham. Stricken.
Well, I think that's good. SX-100 is a really nice machine. I have one myself. Like I said, it's my one of my daily drivers. But I think in the morning I'm going to do a nice sharp alignment on this, which is a bit of a procedure I do, a little different than the manufacturer, only because there's more modern equipment to get a sharper alignment going. But I think we've cured it between the bad resistors and the bad tubes, and certainly we've cured the shock problem. That was kind of sort of bizarre, but here we are, it's done. So the next step is in the morning, I'll begin the alignment procedure, and then we'll shake it down again and see how it does. And I'm pretty sure, like I said, because we changed a lot of the plate voltages, there's going to be a lot of impedance changes and new tubes and whatnot. It's going to benefit greatly from a full alignment and calibration. So we'll carry this video on in the morning. Okay, so the first step of alignment of an SX-100 is determining what frequency exactly the two crystal oscillators are running at. And they are for lower and upper sideband. One of the crystals is 1600 kilohertz. The other crystal is 1700 kilohertz. So if your crystals are pretty close on, or your oscillator runs close on to 16 and 1700 kilohertz, you can go ahead and do the alignment at 1650 kilohertz right down the middle. But if your crystals have drifted off, a little bit, sometimes you may have to change the IF a little bit to match, because you want to put the IF signal right down the center of those two crystals. So if we can look, we can see one of them here running on the screen, and that's lower sideband, and that's upper sideband. So on this display, we can see that the level of them, the actual amplitude, if you will, is about the same. So next we need to determine the frequency. Pardon me if I get in the way of the camera. And this one here, this is 1600, as you can see in the top corner there. Let's see what our marker says. And that's pretty darn close. That doesn't say that I would need to make any kind of an adjustment to the IF. So now let's check. That's like, I don't know, less than 4/10 of 1 hertz. It's pretty close. Either with the 100s, they're either quite a bit off or they're right bang on, I find. So let's just change frequency if I can. Okay, so now we're going to go and look at the upper, and there is the upper signal. And let's see what frequency it is at. It looks like it's even better. Yeah, okay, so we know that our crystal oscillators, we're going to look at the schematic of this in just a second. We know that our crystal oscillators are running pretty much on frequency, and that the actual amplitude of each of them is almost identical, which is great. So we can proceed on to do the rest of the alignment. But let's just look at this on the schematic for a second. Here we are looking at this oscillator we were just talking about. Second converter sub-chassis, it says, is mounted on the top of the chassis. It's within the dotted line. It's another chassis mounted on top of the on top of the main chassis. And you can see here now, this is marked as the 1600 crystal, and this is the 1700 crystal. So that's how they derive upper and lower sideband, which is kind of cool. You've got an upper and lower sideband switch on this radio. So the first IF of 1650 goes down the middle of those two, and you can engage the carrier on either 50 kilohertz off either side of that per sideband, which is rather nice. So it's kind of a very interesting setup to think about. But this is where the conversion to 50 kilohertz is done. This is a dual conversion radio. So our first stop is 1650. Then we pass through this secondary oscillator and second mixer, and it puts out 50 kilohertz IF, 50.5, sorry, IF on the other side. Kind of cool. Okay, so I think prior to proceeding to alignment, since we've got the spectrum analyzer software up and running, we should set the, this is the crystal calibrator, and you'll notice it's off a little bit. So let's put it on frequency right bang on here. If I can get on it, that is. Changing my display mode for a tighter resolution. There we go. That's right bang on. Okay. We're set up to do the 50.5 kilohertz alignment. We've pulled the first oscillator tube so that VFO oscillator doesn't interfere with us. This is all manufacturer's instructions. We're pumping in a 50.5 kilohertz signal at the beginning of the 50.5 IF chain. On this meter, we're monitoring the detector voltage. So we're going to be tuning for the desired detector voltage, or a peak of detector voltage, sorry. The manufacturer has asked that I keep the output of that at 1 volt or above while tuning, so we're going to do that. So we have 4 coils to tune that are all on the top side of the radio, but at least you can hear watch this. You can maybe also let me know if you want to see more of this type of stuff. I know I see that some people skip over it with the YouTube analytics. I can see what you're watching and what you're not. And other people go, yeah, we want to see more. So maybe maybe you could bark up and say, yeah, we want to see more of that stuff. So here we go. We're going to do, takes a little bit to get on each of these transformers here now. So we're watching this meter here. Okay, so we got a little bit of a gain there. Moving on to the next transformer. T3, then T4. You're following along, you got the schematic. Okay, so now we're going to turn our signal generator down. We want to try to hold you around a volt or so. There we go. Back to the transformer. Well, that was out quite a ways. Wow, back to the signal generator, we're turning the signal generator down even more. I've got a feeling we're going to do this a lot. Wow, we're going to pick up quite a bit of sensitivity just by sharpening up this alignment. Yeah, this has not been, somebody's been fooling around without the proper test equipment. That's way out. Turn that way down. Now we finally get into our peak on that one. That was T4, that was so far out. So now we're on to T5. T5 is a little trouble to get onto, so bear with me. There's our peak with T5. That was quite a gain, so we've got quite a bit of sensitivity coming back to my signal generator, dropping down to just about nothing. T6 now. Wowee, another big gain. Yeah, this set definitely needed alignment. Well, between the change of plate voltages and years, and maybe somebody not having the right equipment. Okay, so we got quite a bit of gain, so I'm going to come down to a volt. We're going to go through those transformers again. We're on T4 now. I think we got a decent peak there. Don't think we're going to get that much better. Same with T5. I think we're there. Last but not least, come on, you can get on there. Yep, that's it. Okay, so that's the 50.5 kilohertz IF set properly. So now I'm going to just pause the camera and I'm going to set up now for doing the 1650 kilohertz IF. So I'll be back in a flash. Okay, we're set up now for the 1650 IF. And this setup is using the Simpsons, where across the speaker terminals is kind of sort of the standard way that a lot of radios are done. Or anyways, this is how the second half is done, is by monitoring the output. There are 2 IF transformers, but each transformer's got 2 slugs, one on the top, one on the bottom. So 2 are accessed from the top, 2 are from the bottom, and I'm probably going to get my head stuck in the camera here. So another thing I'll point out is that because of the microphone that I use, it's got this noise canceling feature that, like, I'm hearing a solid tone all the time, but I know you folks at home, the tone drifts in and drifts out. It's a little bit confusing. So just watch the meter, because my microphone plays funny tricks with the tone. It tries to cancel it out. So I don't know if you can hear the tone, but we can see the meter raised up a little bit. This guy here. So we want to tune per peak all 4 slugs, 2 coils, 2 transformers. On the first one, a little bit of a gain there, nothing wild. Let's do the bottom of that one. If I can get on it. Here we are. Nothing crazy there either. A little bit maybe. Nothing crazy there. Top of this one. Finally on it. A little bit. I'm going to turn my signal generator down here just a little bit. A little bit of a weaker signal. Makes for a sharper tune. Let's see what we get out of that. Okay. Okay. Don't think we're going to get the much better last one. There. That's a good as it's going to get, I believe. So the 50.5 1650 is done. The second chassis oscillator is done. Crystal calibrator is done. I did the BFO earlier. Sorry I didn't film it. All I did was I used the poor man spectrum analyzer to make sure that when the BFO knob was on 0, the output of the BFO was exactly 50 kilohertz. So that's done. So I'm going to flip the radio down, give it a try, but the next real thing to do now is to put the case back on it and then go through and do the RF alignment. But again, I don't think that you guys want me to bore the pants off you because it's a long, boring, dry procedure. The fun was in doing the IF. It was rather complex. So let's just flip it down or two around quickly, and then we'll put the covers back on it. Okay, here is the 80-meter band the customer complained about. We'll just do a short demo here.
In year 2024, we're going to have to take it to a vote, I'm afraid, Pete, right? Well, you know, I'm prepared for the worst, Chaz, but on the other hand, we need to be open and democratic and take all comers, all right? Well, I don't know. I mean, it was quite obvious that we let you in here with that Yaesu. You know, it was bad enough when you had the Kenwood, but now that you have the Yaesu, I'm going to have to talk to the master of ceremonies, and that would be Bob, Orlando Bob, and see what he thinks about all that. Well, I refer to him as spectral growth, Bob, but you got to remember, this is radio, not television, guys. No. Spectral growth, or it might be Bob, but spectral regrowth is Jim.
So, as you can see, it's no longer deaf. It's pretty hot on all the bands. I'm pretty familiar with this radio, and it seems to be functioning very well. So the last step of the journey is, as I said, to throw the case on it and do the RF alignment and calibration, which is not a big deal. And so I guess with that, well, maybe you can tell at me if you folks want to watch me go through that process, which is kind of long and boring, or you're okay with just reading the manufacturer's instructions. But I guess with that, I'm going to end this video now. And I hope you kind of learned the approach to a repair is common, cool, and step by step. Working step by step, you can always overcome even the most buried of problems. Eventually, working methodically and slowly, and not panicking and not being upset or lost, you can get to the root of the problem. So, if you're enjoying our series of videos, please subscribe. We could really use the support. And I guess with that, we'll see you again in the next one, and we'll call this repair successful. See ya.